Alright, algebra classes, this is Mr. Kim. Again, sorry I can't be here with you. I think I told most of my classes, but if I didn't say so, I'm going to be at a training today on campus over at a different part of it. So this video will be on my website. So again, you can log on and find it. You'll also find a video for yesterday's lesson, kind of short video explaining how to do absolute value equations. And we're also going to grade homework at this time. So if you haven't already, you should take your homework out and trade and grade. We're going to get ready to grade in 3, 2, and 1. Alright, so here it is. You're going to notice that the answers do not have x equals, for example, number 1, x equals negative 2, comma 2. That's okay. As long as your partner has these answers, we're okay. Now you'll notice that the point total is 42, which means there's 2 points for every problem. We had 21 questions. So I'm just going to assign 2 points, just to keep it simple. So if they get the first one right and the second one wrong, then they miss 1. So 2 points for every problem. Now you might count number 10 and say, hey, Mr. Kim, there's only one answer. That's okay. Let's just make it minus 2 if they get it wrong. So if they gave an answer here, that means they gave 2 incorrect answers, so minus 2. Same thing. If they, for example, number 12, they put no solution and they should have got answers, then minus 2. So every problem is 2 points. If they miss half of it, it's minus 1. If they miss the whole thing, minus 2. So teacher, at this time, please pause the video so that the students can finish correcting. They should be traded and graded, and they should not be correcting their own papers. Thank you. Alright, class, here we go. Hopefully the answers make sense. If you have any questions, email me or see me on Wednesday in the morning, and I'll be able to help you. Hope you have your notes ready, because we're going to take a lesson today, do a lesson with notes like I usually do if I'm absent. This is lesson 3.6 part 2. So we're doing absolute value inequalities today. That's a little different from equations. So on Monday we did equations, today we're doing inequalities. That means less than, greater than, shading, graphing, all that stuff. So you're going to basically solve inequalities with absolute value and graph the solutions today. So that's today's lesson. Moving on in 3, 2, and 1. Again, this video will be on my website. Please go there and check it out. Alright, absolute value inequalities. In a nutshell, there's 2 kinds. There's AND problems, which we reviewed last week. And then if there's AND problems, that means there's OR problems. But for right now, these are AND problems. And on your homework today, you're going to see problems that look like this. Absolute value on the left, inequality number. Absolute value, inequality number, and so on and so on. As long as the variables are on the left side and the absolute values are on the left side, any problems that have less than or equal to or less than, those symbols will be considered AND problems. So some of you might be thinking, okay, well, if they flip them around, we'll call them OR problems. But for right now, as long as they're less than or equal to, you're going to consider these AND problems. So let me show you real quick how to solve these problems. You'll remember AND problems had inequalities they had 2 inequalities. So basically, I'm not going to give you the why, like how it works out, because we really don't have time for that right now. But I'm just going to show you what to do. Okay. So in this case, let's label this AND so you remember what you're doing. In an AND problem, you're always going to do one thing first. You need 2 equations or 2 inequalities, because yesterday when we did these problems, we had 2 equations and we solved them. So same concept, you're going to rewrite this without an absolute value sign. You're going to keep the positive number 2 on the right side, but we're going to add or write, again, this inequality symbol right on the left side. And when we do that, we're going to change this 2 to a negative 2. So this is similar to yesterday in that you created 2 equations with the 2 and the negative 2. Same concept, but now we're putting it together in one line. And this part right here should seem familiar. Last week we had a quiz, and on that quiz we had AND inequalities and OR inequalities, and this is where they come from. So if you remember, we're going to isolate the y, this y by itself, by moving whatever's next to it. We're going to add 5. And on the quiz last Friday, we had some mistakes here for some of us that didn't get these problems right. You would add 5 here, and you added 5 to the right side, but you forgot about the left side. There are 3 sides, left, middle, right. So we're going to add a 5 over on the left side as well. When you finish this up, the 5's in the middle cancel out. Now you're left with just some addition and subtraction. So in the middle we have our y, less than signs all the way around. Add the 2 plus 5 on the right, that's a little 7. Add the negative 2, positive 5, that's a 3. So now, that's your answer, 3 less than or equal to y less than or equal to 7. And if you remember how to graph these are going to have shading in between. So give me a 0, give me a 3, give me a 7, so we know where the numbers are. These are closed circles because they have the equal to sign underneath, so close it up. And because these are AND problems, you should shade in between the two numbers 3 and 7. So pretty much the only new part is getting from the original problem to this second step. From here down, we already know how to do this because we already did it last week. So hopefully you remember. If you don't, go back in your notes in lesson 3.4 and go back and check how do you solve it from here, the beginning of the red problem down. But today is basically from here to here. So today's problem is just getting from there to there. And then the rest is history. Let's continue on. Number 2. Same problem. Keep the x, lose the absolute value symbol, keep the 15, keep the inequality sign. Then on the left side, we're going to introduce the same inequality with the negative 15. All right? So from here, I think we're done. There's nothing around my x. There's nothing to divide or add or subtract or multiply. So our problem is done. Oh, by the way, the final answer we should circle here. So here is the final answer. So since we're done, go ahead and draw a number line. We're going to graph negative 15, 0, regular 15, positive 15. And we figure out the type of circles. These are open. And since this is AND, we shade in between. Hopefully this is making sense. It's very, very easy. Okay. Let's go on to number 3. Go ahead, if you haven't copied this problem down, copy it down. Again, we're going to lose the absolute value symbols. And we're going to create the right side and then create the left side. So if you notice in all 3 problems, we put a negative on the left side. We kept the positive on the right side, right? Positive 15 and positive 2. So solve this out. I'm going to show you real quick. Add 5 to both sides. I'm sorry, add 5 to all 3 sides. So we're going to get a negative 2 less than 2t less than 12. Turns out 2 is going to divide into all of these. So we divide, 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 and our final answer will read negative 1 less than t less than 6. From here, graph on a number line, 0, negative 1, and 6. These are open circles. So open, open, shade in between because it's an AND. That's pretty much AND problems, which leads us to the next type, OR. Alright, let's move on in 3, 2, and 1. Alright, OR problems, if you take a look, will have greater than symbols. So OR problems make greater than symbols. So we're going to do this just like we did last week. We're going to separate these into 2 inequalities so you understand the difference between an AND and an OR. Remember, greater than symbols. So all you have to do is look at the original symbol. As long as the absolute value is on the left side, left side, left side, this is always going to make an OR problem. So the first problem we're going to make, okay, is the original, and we're going to put it on the right side just like before. Now, there's one quick trick here. Again, I don't have time to go through every single thing, but I will show you what you need to do. When we put this 7 and make a negative 7, we have to change our inequality sign as well. So some of you might be confused by this. I'll give you, oh, whoa, hold on, let me back up. This 1 on the right side should be 7, so let's fix that. Just because I make a video doesn't mean I always get it right the first time. Alright, so some of you are wondering, okay, I understand why we have negative 7 because we did this in the AND problems, but why do we have to flip the inequality around? Brief explanation is, remember when we change the value of the side, right, when we change it from negative to positive, we have to flip the inequality around. Basically, that's what's going on. So 7 was on the the less than side, now negative 7's on the greater than side because we changed the value of the right side. That doesn't make sense. Watch this video again, but you have to do it every single time. Okay? And we're going to put the word OR in here to help us remember this is an OR problem. So solve minus 4, y less than negative 11, or on the right side minus 4, y greater than 3. And you'll notice that these inequality signs are like kind of like arrows, and they point away or outward, right, to the left and to the right. So that's again another reason why we have to flip this inequality sign around. Most kids get the -7 right. They forget the inequality, which is a big step because if you don't flip the inequality, you're going to get it wrong. So let's graph this. We need a 0 for the middle, a 3, and a -11. These are going to be open circles, and these are OR problems, so we know that they should be graphed outside, so going both to the right and to the left, so the middle is not shaded at all. So let's try to apply this same technique right here over for 2 and for 3. So we're going to create our original equation, put it on the right side. I'm sorry, forget the equal sign. Greater than or equal to 7, making all kinds of mistakes today. Put an OR in between, and on the left side we'll keep it x -7, and we got to flip this inequality sign around, so that'll be less than or equal to. And guess what? I don't need to solve anything. No adding, subtracting, dividing necessary. So we found our answer. That's it. I keep forgetting to circle my answer, right? Let's go back to the first one and circle. All right, so we're done here. Graph, -7, 0, +7. These are closed circles because of the equal to signs underneath. So we just shade and shade. Oops. And these are OR problems, so just follow the quote arrows or the inequality signs, and we're going out, left and right. Okay? Hopefully you're getting the hang of this. Number 3, again, this is a greater than symbol, matches this, so we're doing an OR problem. So the first problem will be 3t plus 4 greater than 15. Basically, the copy version, it's a copied version of the first problem. The second version will have 3t plus 4, the -15, and because we changed the value in the problem, we have to change the inequality as well. So from there, subtract 4 for both inequalities. Subtract 4, subtract 4. Subtract 4, subtract 4. Now I'm going to solve these individually from now. I just wanted to show you that you are doing the same thing basically to each inequality. So that's -19 divided by 3. T is less than -19 over 3, and it's okay if you get a fraction. That's allowed. Don't worry. I know some of you are panicking, saying that doesn't look right. It's okay. 15 minus 4 is 11 divided by 3. T greater than 11 over 3. We have two fractions. That's okay. It doesn't mean we're wrong. Some of you do believe you are, but we're not. 0 in the middle, -19 over 3 on the left side, and +11 over 3 on the right side. So from there, all we have to do is go ahead and put the correct circles down, open, open, and shade to the right, to the left. All right, that's pretty much OR problems. All right. So what we're going to do next is take a look at some problems. We're not going to actually do all of them, but I just want you to take a look at them. So hopefully you're done. We're going to move along in 3, 2, and 1. So what you're going to see on your homework is stuff like this. When we break it down step by step, it's easy. But when you're left alone, that's where it's hard. So before you even start the problem, identify what kind of problem you're going to do. Is it an AND problem? Is it an OR problem? So for number 1, if I were you, this is how I do it. This is a greater than symbol. So after you write this problem down on homework, let's say it was a homework problem, after you write it down, just label it OR. So you know you have to separate and create two different inequalities, and you're also going to do something with that inequality sign. You're going to flip it around when you change that to a -4. Number 2, let's say I solved number 1, now I'm moving to number 2. That's a less than or equal to. That's going to mean an AND problem. So you just label it for yourself. This is this is not for anyone but yourself. So you get these right. Same thing for number 3. I see a less than sign. That's going to be another AND. And lastly, number 4, that's going to be a greater than sign, so that's going to be another OR. Right, just as a recap, these ORs, you're going to create two equations. We're not going to solve them. I'm just going to show you. You basically write the same equation twice, except the answer, the right side, needs to change to a negative, and when you change the value, you change your inequality sign as well. That's pretty much it. For number 2, you create two problems simply by recreating the original equation on the right side, and on the left side, you put the negative there. And that's the main difference between solving an OR problem and an AND problem. Hopefully this makes sense. That's all there is for me. Please do this step. For those of you that are taking your time and trying to get this right, this is going to save you a lot of time and a lot of mistakes. All right, good luck. And these are going to be, this video is on my website, the private haiku site. Please check, and we will see you on Wednesday. Good luck, and get ready to start your homework.